5C 1 through 3. Number 1. For women in Haynes 2, the average height was 64.3 with an SD of 2.6. Using the normal curve, estimate the percentage of women below 66 inches. So I draw my normal curve. And I have a mean, or an average, of 64.3. And I know that the SD is 2.6. Remind me again what the SD tells me. Right, it's the average distance of each number from the average. And actually, it's a little bit bigger than that because we did the root mean squared. But it turns out we like it to be a little bit bigger, and sometimes we even like it to be a little bit bigger, but that won't be until a lot later. Okay? So, I know, just as a review, if I go right 2.6 and left 2.6, I capture 68% of the people. And that's true of any normal curve. If I go right another 2.6 and left another 2.6, then I capture 95% of the people. And if I go out to 3 SDs, I capture 99.7. And there really aren't people beyond that. Anyone out there is extremely rare. They do happen, but there just aren't many people over there. Okay. So I want to know how many women are 66 inches or shorter. Well, I need to compute a z-score. A z-score is the number I get when I convert any normal curve to the standard normal curve. And the formula is simply value minus average divided by SD. Why do I always want to put the value first and the average second? Then my signs will be correct. Anything that's to the right will end up being positive, and anything to the left will end up being negative. So I'm going to take 66 minus 64.3, and I get 1.7. What does that number tell me? I want to know how many people are 1.7 inches taller than average and below. So that's my cutoff. Anyone that is 1.7 inches taller than average, I want to add all of them up from the low end all the way up to that plus 1.7. Now I need to convert it into a z-score by dividing by 2.6. Seriously? How did my calculator get to the other screen? There we go. All right. 1.7 divided by 2.6. What does that tell me? 0.68 SDs taller than average. Okay. Now, I need to do shade norm from the left side all the way up to 0.68. I'll clear my draws. Shade norm from, I'm just going to leave that. If you don't have this kind of calculator, what's the lower end have to be? 5 or lower. Anything smaller than negative 5 would work. Up to 0.68. And I should get this area here. And I do, 0.75. So 75%. Okay? All right, between 60 and 66. So the nice thing is I already know 66 is 0.68. That's my z-score, which is kind of nice. Now all I need is 60. And then this is 64.3, and my SD is 2.6. So I will do 60 minus 64.3, which is negative 4.3. Divide that by 2.6. And I get a z-score of negative 1.65. So I need to do a shade norm from negative 1.65 to 0.68. So negative 1.65 to 0.68 and I get 70.2. Why does that sound reasonable? So the last one was 75. Why is this one bigger than the one we just did? Because it includes this little area out here. And actually, we are 1.65 SDs, so I should probably move this further over. And there's just not much area in this little tail over here. There's 5%, basically. All right, and above 72 inches. So 64.3. 72 is going to be way over here somewhere. 72 minus 64.3, which is 5.7, 7.7. Divide that by 2.6. And I get 2.9. How many people are going to be right of 2.9? Very few. What's that? Less than 1%, because if I go out, if I do -3 and 3, that's 99.7%. And we're not quite there, but we're really close. So it's going to be about half of the leftover, which is only a third, 0.3%. So we're going to take 0.3% and cut it in half, basically, which is 0.15%, which is extremely small. Let's see what the calculator gives us. So from 2.96 to 5. And you might not even be able to see the shaded area. Yeah, you can't even see it. It's this little tiny space over here, and I get 0.0015. So 15% of 1%, which is extremely small. Okay, 2. In a law school class, the entering students averaged about 160 on the LSAT, and the SD was about 8. The histogram of LSAT scores followed the normal curve reasonably well. A, about what percentage of the class scored below 166? So my average is 160, and my SD is 8. So I want to go over here, and here's my inflection point. Am I going to be left of that inflection point or right of that inflection point? Left, because I need to go up to 166, and that's a +6, which is smaller than 8. So 66, 166. Value minus average is 6 divided by 8 is 3/4, or 0.75. So what am I going to plug into my shade norm? From -infinity up to 0.75. And I'm not even going to clear my draw because you can't even see the old picture. So from -infinity to 0.75. And it should stop right before that 1, the +1, and I get 77%. All right, for the next one, one student was 0.5 SDs above average. About what percentage of the students had lower scores than he did? What do we need to do there? So you could convert it back to a score, right? You could say, well, 1 SD is +8, so 164, and then I would need to do 160 minus 164 divided by 8, but what am I going to get when I do that? 1/2. So we didn't even need this. All we needed to do was graph from -5 to 0.5. But it was nice. The fact that you could figure out that he scored 164, that's important because we're going to be doing that a lot. So I will go from negative big number to 0.5. The area should be a little bit bigger than like 60%, so 69.1. Okay, that's how many people are below half an SD. Okay, number 3. Oh, wait a minute. Back to number 2. See the numbers in the parentheses? LSAT scores range from 120 to 180 among all test takers. So apparently when people take the LSAT, they always seem to score between 120 and 180. 180 must be the high. And I don't know if 120 is the low or not, but whatever. The average is 150 and the SD is around 9. So, is it reasonable to say that the people in this particular class who had an average of 160 are smarter than law students in other classes? Yes? How come? So the average went up. Okay, so it says in a class, the students averaged 160, and the average among everybody who took the test is 150. So, do we suspect that the law students in this particular class are, we'll say smarter, but did better on the test than other law students? And I would say no. We don't know that. Because did everybody who took the test end up in a law class? No. How come? Well, if you fail the LSAT, guess what happens? You don't get into law school, right? So this is one place where the data could be a little misleading. You could say everybody who took the test scored a 150 average, and then this particular class scored a 160, so these must be better law students than the students in other classes. But we have no idea what the other classes look like. Is it reasonable to say that these students did better on the LSAT than the average of everybody? Yes, but a whole bunch of those everybody's failed the test and didn't get into law school. Does that make sense? So while they did better than the average on the test, you can't say that this class is above average when it comes to law school classes. In order to do that, you have to compare law school classes to law school classes, and we don't have that second piece of information. All right, 3. So in figure 2, the percentage of women with heights between 61 and 66 is exactly equal to the area between 61 and 66 under the, we have a choice between normal curve or histogram, and approximately equal to the area under the blank. Okay, which one goes first? Histogram. Histograms are exact because that's the data. The area in the histogram is exact because it is the actual data. And they approximate, they're about the same as the area under the normal curve. Okay? And the cool thing is, the more people you survey, the closer the histogram comes to the normal curve. If you only talk to 6 people, will your histogram look like a normal curve? No. But as you talk to 100 or 500 or 1,000 or 5,000, the more people you talk to, the closer and closer that gets to the normal curve.